Elastic collision in one dimension. If the two bodies after collision move in a straight line, the collision is said to be of one dimension. Consider two bodies A and B of masses m1 and m2 moving along the same straight line in the same direction with velocities u1 and u2 respectively as shown in the figure. Let us assume that u1 is greater than u2. The bodies A and B suffer a head-on collision when they strike and continue to move along the same straight line with velocities v1 and v2 respectively, as you can see in this diagram. From the law of conservation of linear momentum, total momentum before collision is equals to total momentum after collision. So we can write the equation m1u1 plus m2u2 is equals to m1v1 plus m2u2. This one is equation number first. Since kinetic energy of the bodies is also conserved during the collision, so total kinetic energy before collision is equals to total kinetic energy after collision. Half m1 u1 square plus half m2 u2 square is equals to half m1 v1 square plus half m2 v2 square. This one is equation number 2. Or m1 u1 square minus m1 v1 square is equals to m2 v2 square minus m2 u2 square. This one is equation number 3. Now from equation first, m1 into u1 minus v1 is equals to m2 into v2 minus u2. This one is equation number 4. Dividing equation 3 by 4, we get u1 square minus v1 square upon u1 minus v1 is equals to v2 square minus u2 square upon v2 minus u2. After solving this, we will get u1 plus v1 is equals to u2 plus v2, or we can write it u1 minus u2 is equals to v2 minus v1. This one is fifth equation. Equation 5 shows that in an elastic one-dimensional collision, the relative velocity with which the two bodies approach each other before collision is equal to the relative velocity with which they recede from each other after collision. From equation number 5, we have v2 is equals to u1 minus u2 plus v1. This one is sixth equation. Substituting v2 in equation number 4, so we have m1 into u1 minus v1 is equals to m2 into v1 minus u2 plus u1 minus u2, or we can write it m1 u1 minus m1 v1 is equals to m2 u1 minus 2 m2 u2 plus m2 v1. After simplifying, we will get m1 plus m2 into v1 is equals to m1 u1 minus m2 u1 plus 2 m2 u2. After taking u1 common in right hand side, we can write this equation like this: m1 plus m2 into v1 is equals to u1 into m1 minus m2 plus 2 m2 u2. Or we can find the value of v1 is equals to u1 into m1 minus m2 upon m1 plus m2 plus 2 m2 u2 upon m1 plus m2. This one is seventh equation. Similarly, v2 is equals to 2 m1 u1 upon m1 plus m2 plus u2 into m2 minus m1 upon m1 plus m2. This one is eighth equation. Special cases. Case 1. If the masses of colliding bodies are equal, that is m1 is equals to m2, v1 is equals to u2 and v2 is equals to u1. This one is equation number 9. After head-on elastic collision, the velocities of the colliding bodies are mutually interchanged. Case 2. If the particle B is initially at rest, that is u2 is equals to 0, then v1 is equals to m1 minus m2 into u1 upon m1 plus m2. This one is 10th equation. And v2 is equals to 2m1 u1 upon m1 plus m2. This one is 11th equation.